Now, this is a line L. It passes through 2 points. 0, 6, which means 0 on the x-axis, means dead center and goes 6 up. 0, 6 right there. 4 minus 2 means 4 across minus 2 down. Key word is plot P and Q on the coordinate diagram and show the line L. It's probably quite important that you label P point Q. Draw your line. Most people got this out. And there you go, that's line L. Everybody happy now? Okay. Next one. Find the equation of line L. When you go to your notes, what two equations are there for the line? There's y minus y1 equals m bracket x minus x1. All on page 19. So if you have out your tables, that'll be a good place to look. You could also have y equals mx plus c. Okay? Now, oh, sorry. Hey, there. Yeah, my fault. Yeah, okay. And does it say K is perpendicular to it? Okay, so K is perpendicular to L and hits L at what point? It gives you a point on the line, doesn't it? 4 minus 2 is on. Is that right? Okay, so we're talking about the equation of a line. 9 times out of 10, you're using the y minus y1 equals x minus x1. The second thing you need to know about these is that when you're finding the equation of the line, you have 3 pieces of information you need. These are the pieces of information that you need to make it work. Do we know what x1 and y1 is? x1 and y1 refers to a point that is on the line. Therefore, x1 is 4, y1 is minus 2. The biggest problem is where do we get the slope from? Is there any keywords in this question that tell us where the slope comes from? Huh? Perpendicular to the old one. So we'll get the old slope, okay? So we'll work with the old slope. We're doing 4 minus 2. I'll call that x1, y1. 0, 6 is x2, y2. I'm going to find the slope formula here, which is y2 minus y1 all over x2 minus x1. So I'm going to get 6 minus 2 all divided by x2 minus 4. So that's going to be 8 over minus 4 slope up. Is everybody happy with slope minus 2? Okay. A slope of minus 2, just a quick bit of revision here. What way do negative slopes go, guys? Slopes. What direction do they go in? Negative slopes go this direction from left to right. Positive slopes go this direction. Okay? So, when we're talking about the negative slope of minus 2, we're talking about the slope of the line that's already drawn. When we get a positive slope, that's going to be perpendicular to that. You need a positive slope to go perpendicular to a negative slope. Does everybody got that? So, what we're going to do, I'm going to tell me how to convert. Can you tell me how to find the perpendicular slope to 2? Turn it upside down and you're basically turning 2 over 1 upside down to get a half. You change it from a negative fraction into a positive fraction. Your slope is a half. Now you can use the formula. You have enough information to work this formula, so it's going to be y minus 2 equals a half into x minus 4, x minus x1. Okay, that's y plus 2 there equals a half into x minus 4. Now this is the part that people start getting confused on. So 2 on the bottom. Anytime you have this equation, have a denominator. You may have a denominator in the fraction position, in the slope position. Whatever that denominator is, multiply it by the other side. And it's every time. Everybody happy enough with that? So what happens then? You get 3y. Oh, sorry, y 6 equals x minus 4. Everything to one side. So we'll get minus x plus 2y. What's 6 plus 4? Is that 10, is it? Oh, 4, yeah, my fault. Plus 4, yeah, it's 8. It's not that one. Here's you get plus 8 equals 0. And after that, one version of the other version of the answer. X minus 2y minus 8 equals 0. Write that. Okay. Now, it says the line K cuts the x-axis or cuts the y-axis at the point R. Find the area of the triangle PQR. So how we get this is the equation of line K is x minus 2y minus 8 equals 0. Would everybody agree with that? As specified before, the point Q, our line K has to be Q and has to be perpendicular to the black line that's already been drawn. Now, to draw a line, if I find 2 points on that line, I can draw that line really quickly. Okay, so here's what I can do. You can choose a value for x, or you can choose a value for y. So I'm going to draw a line using the of a line. Okay, ready for this? Choose x equals 0. What happens when x equals 0? What's left over? Minus 2y minus 8 equals 0. Get y on its own. Minus 2y equals 8. 2y equals minus 8. Y equals minus 4. That means that this point 0 minus 4 is a point that's on this line. If we want to find out the x-axis intercept, and I'm quite aware that we already have 2 points on it, I'm going to do the x-axis intercept anyway. Okay, hopefully it'll fit it. It's going to be this one here. So, when I turn y into 0, what happens? When I turn y into 0, we get x minus 8 equals 0 and x equals 8. That means that point there is the point 8, 0. When I choose y to be 0, the x value is 8. When I choose x to be 0, the y value is minus 4. So, in effect, you have these two green points here. And what you'll find is when you draw them together, and you'll find that they'll actually go to the point Q anyway. So, draw your line. Now, it's asking for the area of the triangle. What triangle is it asking for? The area of the triangle? PQR. It specifies that point R is where the line K touches the y-axis. It must be R. That's Q. That's P. It's referring to this circle here, or this triangle here. Everybody happy enough with that? Now, it's a right angle triangle with 2 choices. Okay, I'm going to do it using the formula, but I'm going to give you a choice a different way. The choices is, because it's a right angle triangle, you can do a half base by height. You can use your distance formula to figure out the distance from here to here. Then you can use your distance formula again to figure out the distance from here to here. And then you can do a half base times height. Only because it's a right angle triangle. Okay? What I would have done, and what most of you decided to attempt to do, was most of you went to your geometry formulas and you wrote down A equals a half x1 y2 minus x2 y1. Okay? Can anybody tell me what's the problem with using that formula? What'd you say? One of the points has to be 0, 0. Is one of the corners 0, 0? No. So what we have to do is we have to change it to a new triangle that's exactly the same size, but has one of the corners centered on 0, 0. So here's how I taught you, okay? What I want you guys to do is pick any point and bring it towards 0, 0. Which point do we choose? We'll choose R because it's easy, isn't it? Just go 4 straight up. So if I go 4 straight up, I turn R, which is 0 minus 4, it gets turned into 0, 0. How do I turn it into 0, 0? I added plus 4 to the Y value. Paddy? Right. Alright. What about the next point? What about Q, which is 4 minus 2? What does that end up becoming? What's 4 minus 2 become when you add 4 onto it? 4, 2. What does P become? P is 0, 6. 0, 10. And automatically, in effect, what you've done is so what I have my new points, and I'm going to call them x1, y1 for this one here, x2, y2, and then I'm going to use that formula there. Can anyone in the class remember what did the two big lines stand for? What if I wrote that down? What's the answer to the modulus of minus 5? It means it has to be a positive number, no matter what happens. So the modulus of plus 5 is 5. The modulus of minus 5 is also 5. It just means area can never be negative. That's all it means. If you want to write that down in your tables now, be my guest. All what it means is that area can never be negative. Okay? So what we do is we get a half, and it's just a matter of filling in the numbers. So it's 4 times 10 minus 0 times 2. It's a half of 40. That equals 20. You did that using the length formula, didn't you?
No, I did half base by height.
But you got the same answer. Yeah, you used the length formula to get the length. Then you did a half base by height. Okay. I didn't use it. I used the area of a triangle formula. Okay. Moving on. Yeah. Now, moving on. This one was reasonably easy, but it caused a lot of hassle, okay? The first thing I want you guys to know is that on page 18 or 19, there's a formula for circles. The formula for circles reads this. Okay? To get an area, to work a circle, you need 3 pieces of information. You need to know the center of the circle, and you need to know the radius. So there's 3 pieces of information that works the circle. Okay? Now, H and K refer to the center of the circle, and R is obviously the radius of the circle. Okay? Now, can anybody tell me what's the center of the small circle? 0, 0, 0. Okay? This means the H value is 0 and the K value is 0. What's the radius of the small circle? Tells me. So, x squared plus y squared equals, it's going to be 3 squared. Now, for God's sake, guys, don't write it as 3 squared. Finish it off. 3 squared is 9. Finish it off, okay? So, x squared plus y squared equals 9. In a nutshell, when there's no values, when it's x squared and y squared on its own, the center of the circle is always guaranteed to be what? When it's just x squared and y squared on its own, it's guaranteed to be 0, 0. Yeah. So, look at part 2. If this has a radius of 3 in every direction, what does that mean about this point here? The center of C2. 3, 0. Now, if it's 3, 0, it means that the H value is going to be 3, because the X coordinate of the center of the circle is 3, the Y coordinate, K value is 0. 3, 0 is the center of the circle. Its radius is 6. How do we know it was 6? Sorry? It's not height, it's the x coordinate of the center of the circle. H stands for the x coordinate of the center of the circle in these formulas. Okay, what are you saying? S, how do we know it was 6? It's 3 here and 3 there. It's 3 all the way across. So basically, it has to be 6. Now your radius value is 6. Use your formula, okay? So when we use that formula, what we're going to get is x minus 3 squared plus y squared equals 6 squared, which is 36. Everybody happy enough with that? Okay. Does anyone in the class remember? How to show that a point is inside, outside, or on a circle? Inside, outside, or on? Okay. Okay. What you have is you simply replace replace x with 2, replace y with minus 3 for whatever circle you want to test. If it balances, it's on the circle. If it's smaller than, it's inside. If it's greater than, it's outside. Now let's sum this off quite easy here. It's very specific. It says show that it's in the shaded region. Can anybody give me a quick description of what the shaded region actually is? It means outside the small circle, but inside the big circle. Okay? So I have to do 2 tests. I get the equation of the small circle, which is this one here, and then I put in my values. I put in for x, I put in 3 for y, and I get 13. 13 is better than 9. What does that mean? Outside. So it's outside C1, outside the small circle. Then I get the equation of my big circle, and I replace x with what, guys? Replacing x and y with what two numbers? 2 and minus 3. So 2 minus 3 squared plus minus 3 squared 36. Put down to the calculator. Now, I think I'm only 10. 10 is smaller than 36. It's inside circle 2. Is that right? As predicted, this part here was the part where everybody got their marks in. Okay. Now, please read the language definition. Make sure there's nothing left behind here. It's a man-made pond. Horizontal lines drawn across the widest parts. 5 offsets, 5 parts drawn at equal lengths along the line. Find the lengths of the horizontal lines and the offsets taking each grid unit is 5 millimeters. Record the lengths on the diagram. Be thorough with your diagram. Easy marks are 15, 15, 15. Just draw 15 all the way across. How do I know it's 15, guys? Each box is worth 5, says in the question. Okay? Each box is worth 5. In the red circle there, okay? Next thing. Count up your box. How many boxes do you have going up there? 4 above, 4 below, which is 8. 8 times 5, 40. Next one. 6 above, 6 above, 6 below. 12 boxes, 12 boxes plus 5 is 60. Next one. 60 again. Next one. 80. 60. 70. So guys, each box is worth 5. Just count how many boxes there are and multiply by 5. So as an example, if I show you one more, I'll show you this one here. From here all the way up to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 boxes multiplied by 5 gives me my 80. Okay? Now, something that some stumbled upon, just happens every year, Sam. Happens every year. Can you tell me what the height of the last one is? Yeah, exactly. So if you do it, what's the answer? 0. It's 0, okay? Why is the last one 0? Because it's not going straight up, it's curving out. Yeah, if it's a right angle, not if it's 90 degrees on the money, it has a height. But if it's like 89, even like something like 89 degrees and just bending ever so slightly inwards, its height is considered to be 0. Because you can see it's actually quite vertical, doesn't it? Now, use the trapezoidal rule in your notes, but what's the problem with it in your notes? Anybody tell me? It's written, okay? H over 2 brackets first plus last 2 times remaining, or 2 times rest. What do equal signs do? Huh? Approximately equal. Exactly. Okay? Ish. Now, therefore, what's your H value, Mick? Your width of your width of the interval. As in, what's the width of each one? 15 is the H value. The way to use H. What's the force height? Force height from here to here? 40. What's the last height? It's what we discussed earlier. 0. What's 2 times the remaining? What's the remaining ones? I haven't taken them into account yet. 60, 60, 80, 60. Plus 70. Now, all into the calculator, okay? And you can write it down exactly as you need it. 15 over 2. Must have it in stat mode from there. 15 over 2. Open bracket. 40. 0 plus 2 times remaining. 60 plus 60 plus 80 plus 60 plus 70. Close bracket. 5,250. It's the width, Sean. Yes. Yep. Now, lad, there's another formula in your notes, okay? The formula in your notes refers to if you have an irregular surface, or any surface for that matter, okay? And what happens is you can get the area of these surfaces. So you can get the area of them you can get the area of them using the trapezoidal rule. Now what happens is, if I ask you what's the volume, and you gotta remember that volume is a 3-dimensional. Volume is 3D. So if you imagine this is now like a lake, as in it's full of water. So if I say like as an example, turn this upside down. Hopefully it comes out nice. If I was to turn that upside down, you can see that it sort of resembles a lake. It should resemble a lake. Okay? So you have your area multiplied by your height. Would you agree with that? Area multiplied by height. Sorry? Basically, when we do the trapezoidal rule, we get a 2-dimensional object. Yeah, it's the difference between a circle and a cylinder is basically what I'm trying to get at. Okay, the trapezoidal rule will give you the area of a circle. If you multiply it by the length that goes backwards, you get the volume of a cylinder. So we're getting the volume of a sort of irregular shaped object. A prism, okay? Prism, guys, is where the shape of the object stays all the way. Remember I was talking about a loaf of bread, it sort of stays similar all the way across. Okay? Okay, so what we have here is at the moment is we have the area of our pond is 5,250 millimeters squared. The depth of the pond is 0.075 meters. Find the final water required to fill the pond. What I'm going to do is I'm going to meet it halfway. I'm going to turn everything into centimeters. 5 centimeters. Would you agree with that? Now, millimeters squared. The problem with that. Here's the problem. 1 centimeter squared is a centimeter by a centimeter. Would you agree with that? A centimeter is the same thing as 10 millimeters. Okay? So length is 1 centimeter squared equals 100 millimeters squared. Happy with that? Now, I'm going to divide this by 100 to turn it into centimeters squared. So I'm going to divide by 100 by 2.5. So 52.5 centimeters squared. And then, not just yet. Okay. Centimeters squared. Now, 1 centimeter equals 10 meters now. Going to keep that as 0.7 meters, actually, now that I think about it. This here, guys, now I have to compare it to centimeters. I have to compare it to centimeters squared into meters squared according to the scaling of the diagram. Okay? In the scaling of the diagram, 1 centimeter squared is the same thing as, anybody? Meters in both direction. And what's 10 meters in both direction? 1 centimeter squared is the same as 100 meters squared. For this question only, not all the time, only for this question, because it's what 1 centimeter was. So multiply that by 100 and you get, we're basically going back where we came from, 5,250 meters squared. That's the face. Then you're going to multiply by the length of 0.75. Please remember, the face is 5250, the length downwards is 0.75. Multiply them by what you get. Am I good with that? Lads, I have to say that was a very hard question. 327.5 meters cubed. So you might have got that answer completely wrong way, wrong unit, everything. You didn't show me how you got it, so you would have got a tenth. Yeah. Okay. What we have here, guys, is the tablet is in the shape of a hemisphere, a cylinder with a hemisphere each end. One thing that you need to realize about hemispheres, and people forget all the time, is this. Basically, it has a radius of 2. This means it goes 2 in any direction. Yeah. So from the center, it's 2 in any direction. Okay? Huh? Grand, yeah. Do that. 18 and 8. Sorry about that. Sometimes if a class has practiced a similar question, we manipulate the question so the other class hasn't seen it. Okay, so that's what often happens here. So what did I change that to 8, did I? And this one up here to 18. Okay, that's grand. Now, so what that basically means is that it goes 4 in every direction. Okay, radius is 4. The radius the hemisphere is 4. Sam, the radius of the cylinder is 4. Okay. Now it says the total length is 18, doesn't it? The overall length of the tablet. So when you're talking about the overall length of the tablet, you're talking that the whole thing is 18. So what does that mean? We need to take away from 18. We need to take away 4 from both sides. So the length of the cylinder is 10. Everybody have that? Length of the cylinder is 10. Okay. Now, keyword volume. Okay. Excuse me, guys. It wants volume. What's the volume of a cylinder? What's the volume of two hemispheres when you add them together? The volume of two hemispheres is actually the volume of a sphere, so you can just get the volume of a sphere and don't even bother halving them because you have two of them anyway. Okay, what's the formula for the volume of a cylinder? Volume of a cylinder, anybody? Pi r squared h plus 4 over 3 pi r cubed. It says in terms of pi. What does that mean? In terms of pi. Put it in terms of pi in the calculator, keep the pi at the very end. Okay, so what we're going to get here is pi multiplied by 4 squared multiplied by h, which is 10, plus 4 over 3 multiplied by pi, which I don't know, and multiplied by 4 cubed. Can I tell me what the answer to that is? Something like 736. Oh. Yeah. 736 pi over 3 units millimeters cubed. Okay, just put all that to the calculator and it'll give you what you're looking for, the volume. Now, RT, 48 of these tablets are sold in cylindrical containers. Okay, which have a diameter of 25. A diameter of 25 means a radius of 12.5. To allow them to fit, the volume of the container is 25 times greater than the volume of the tablets. Find the height of the container. Well, each tablet is, we did earlier, each pill is worth 736 over 3, isn't it? Pi. Multiply that by 38. So 736 over 3 pi. Multiply all that by 48. 1177. 48 tablets. 11776. I know. Tell me about it. Yeah, I think so. Okay. Yeah. Pi. Now, that's 48 pills. Yeah. 48 pills. You have to make it 20. How do you make it 25% bigger? You multiply it by. If I multiply it by 1.25. If I want to make something 31% bigger, I multiply by 1.31. If I want to make something 20% smaller, I multiply by 0.8. You just take 20 away from 100. So if I want to make something 25% bigger, multiply by 1.25. I'm going to ignore the pi part maybe. I'll see what it comes out as. 14,720 pi. Now, what did we say? It's in the shape of a cylinder, so that's the volume of a cylinder. Pi r squared h has to be equal to that. What's my r squared? My r squared is 12.5. So what I'm going to do here is I'm going to have to solve what h is. So anybody idea to do that? I'll solve what h is. This can. What about the 12.5? Divide it. So 14720 divided by 12.5. Anybody tell me what that is? Sorry? I multiplied the volume of all 48 pills by 1.25 because the volume of the container is 25% bigger than the volume of 48 pills. Okay, so it's 24.2 or 94.21. Now, find the dimensions of the largest label that will fit onto each container. Give your dimensions correct to the nearest centimeters. Please remember that a cylinder, its net looks something like this. Remember we did nets not too long ago? Where do you put the label on? Even this thing here, where does the label go? At the sides. You're talking about this part here being the label. Its height is 94.2. Can anyone in the class tell me what is the length? Who said 2 pi r? 2 pi r. How'd you get that, Cormac? 2 pi r. 2 pi r, which is this circle here, it has to match up exactly on the top of the diagram. Otherwise, it doesn't fit into a perfect cylinder. So when you bend that part in, when you fold it up, it comes a circle on top, which is the circumference of the circle. Okay? So, find out what 2 pi r is. So L equals 2 pi r. L equals 2 pi multiplied by 12.5. It's 25 pi. What is 25 pi? 78.54. So, what does it mean by dimensions, guys? Dimensions. What does that mean? Dimensions. What is length and height? Well, its height's 94.2 meters or centimeters or millimeters. Millimeters. And its width is 78.45 millimeters. Now, I haven't actually earned full marks yet either. What have they done to make this question even harder? What does it say? Nearest centimeters. So I have to divide everything by 10. So I have to turn that into 9.42 centimeters, and then turn that into 7.845 centimeters, and then I can round it off to 8 and it says the nearest whole centimeter, so it's 8 centimeters by 9 centimeters. Very tough question at the end of that. Okay. Last one. Thank God. Now, we have a cylinder and we have a cone. And it says is that when you add them both together, it's 408 pi. Ready? So, the sphere is this much, and the cone is this much here. Fill them in. 6, okay? So, what we can do is we can find out the volume of the sphere, guys. Excuse me? Find out the volume of the sphere. 4 over 3 pi times 6 cubed. So 4 over 3 pi 6 cubed, 288 pi. Now, when that's 288 pi, when you add it on to whatever this thing is, you then find out that the combined total is 408. Most of you guys said they were equal in volume. It never says that. It says when you add them together it's 408. It doesn't say that they're equal in size. Okay, so that was a mistake. So take 408 pi minus 288 pi, and that gives you 120 pi. The volume of the cone is 120 pi. So yes, and the whole point of the question now is to find the height of the cone. So the whole point is, can you find the height of the cone? So I'll write down a third pi r squared. So r squared is 6 times h, which is the point of the question, and that's going to equal 120 pi. What cancels off both sides? Pi cancels, and that's going to be a third of 36, which is, just put all that into the calculator and you get 12. So you get 12h equals 120, h equals 10. 10 what? 10 centimeters. Okay, we alright with that? Now, finally, the cone and the sphere are melted down. They are then melted down to make a larger cone of height 17. Find L, the slant height of the larger cone. Okay, here's the problem. The problem is that both of them are melted down and they are turned into a new object, a larger cone. We do not know the radius of this new cone, but what we do know is we know its height to be 17. We don't know its radius and we don't know its slant height. Okay, some of you use the radius of the old cone. It doesn't say that they're the same radius, so you can't do that. What do we know about the volume of the new cone? Anybody tell me what do we know about the volume of the new cone? Sorry? It's the same as 408 pi, because both of the old objects were melted down to make the new object. So we say a third pi or squared h equals 408 pi. 1/3 pi radius squared we haven't got a clue about. H is 17 equals 408 pi. Now here's the hard part. What cancels? What cancels? Pi cancels. Now we're going to have 17 over 3 r squared equals 408. What can you do with the 3? It's called cross multiplication. What happens to the 3? The 3 multiplies by the 408. What happens to the 17? It's multiplied by 17 on the left, which means what? It's divided by 17 on the right. Then we get 408 multiplied by 3 divided by 17. 72. R squared equals 72. What number, when you multiply it by itself, gives you 72? You press the square root sign and you get 6 root 2 or 8.48. I was going to go for 6 root 2. Now go back to the start. You now realize that this here is 6 root 2. Was that what you were asked for? The radius? What were you actually asked for? You asked for the slant height. Anybody know how to get slant height using radius and regular height? Pythagoras' theorem. L squared, the slant height, equals the regular height plus the radius squared. L squared therefore must be equal to 17 squared plus 6 root 2 squared. L squared equals what's the 17? 17 squared plus 72 root 361. What's root 361, anybody? 19. Who got that one out completely? 19.